Hello, welcome back to the fourth part of our discussion on thermodynamics in Chem 2. This is Dr. Rhonda Kofelt. And in this one, we're going to do some calculations based on using the Hess's law and then combining that with our delta G0 reaction. And then we're also going to look at a way to do the free energy at a different temperature other than the 25 degrees. The nice thing about this is it already is dependent on the temperature, so you don't have to have another equation. You just plug in whatever the temperature is and it'll work. All right, so your delta G0, the reaction we've said is the sum of all the products of delta G0 minus sum of all the reactants, and that's exactly what we saw in entropy, and that's exactly what we saw in enthalpy, okay? And so at temperatures other than 25 degrees and a negligible change in these, then the delta G is equal to this formula. And so we can then apply that formula into getting these ready for us. So when we do this, though, we have got to be able to have the delta H numbers and the delta S numbers. And notice that this is formation, okay? So these are the delta H0 of formation in kilojoules per mole. So the first thing I'm going to do is I'm going to calculate the delta H0 of the reaction. All right, and so in the delta H0 of the reaction, I've got for my delta H's, and then I'll have a place for my delta S's. So I've got a negative 296, sorry, 0.8. And oxygen is a 0 for my delta H's, remember, because anything that's elemental. And then a negative 395.7, and these are all in kilojoules per mole. My delta S is going to be in joules over mole times K, and there are no zeros in your delta S, so you've got 248.2, 205.2, and 256.8. All right, so those are the sets of our numbers. And so just like we've already learned, we are going to do our products minus reactants to get your delta H and your delta S. Okay, so my delta H0 of reaction is going to be equal to a negative 395.7 kilojoules minus a negative 296.8 plus 0 kilojoules. That's going to equal a negative 98.9 kilojoules. And I know this is a delta G problem, so I'm just going to go ahead and convert this to joules because they are going to both have to be in the same thing. So there's 1,000 joules in 1 kilojoule, and so that's going to give me negative 98,900 kilojoules. So that's going to be my delta H number, negative. Okay, then second, I'm going to calculate my delta S0 of reaction because I have all the numbers to do that as well. So my delta S0 of reaction is going to be 256, because remember they're all positive numbers, 0.8 joule per mole K minus 248.2 plus 1/2 times 205.2, and these are all joule per mole K, right? except now since I'm multiplying them each by moles, so there's one of those, and a half of those, then that takes the mole off of it, and so I'm going to actually have joules over K, and so that's going to be a negative 94.0 joules per K. That's my delta S0 of reaction. And so now all I have to do lastly is calculate the delta G at 25 degrees C. So I know that is 298 K because I have to do that in order to have the proper units. So delta G0 reaction is going to be equal to the delta H0 reaction minus T times delta S0 of reaction. So now I just go back and I pick up my numbers. Delta G0 of reaction is equal to a negative 98,900. That's why I converted it to joules, so that they will both be the same units, minus 298 times a negative 94 joules per K. That's K. All right. And so my delta G0 of reaction is going to be equal to a negative 70,900 joules, or a negative 70.9 kilojoules. And since that is a negative value, it will be spontaneous, because the only way I know for sure if it's spontaneous or not is if the delta G is negative. Here's one for you to try. Now, the last problem in this set we're going to do is calculating if your temperature is different from 25 degrees C. And the good news is that it's very easy. It's the same formula. You're still going to use this formula, and you just use whatever the new temperature is. So they're telling you you're going to do it at 125. So 125 plus 273 is 398 K. So 100K higher. Now I'm still using my numbers from the other set. So my delta H0 of the reaction that I already calculated was a negative 98,900 joules. My delta S0 reaction was negative 94.0 joules per K. And so now my new temperature is 398. And all I have to do is plug that into this formula, this delta G formula. Now, if I hadn't given you, if I hadn't said use the information from the other problem, you would have had to calculate the G's and the H's and the S's from a table or whatever. But since we already have them, I made it easy on you. So the delta H0 of the reaction minus T times delta S0 of the reaction. So I plug and play, equals a negative 98,900 joules minus 398 times a negative 94 joules per K. Sorry, and that's K. And so I end up with a negative 61,500 joules, or a negative 61.5 kilojoules. Now, that is still spontaneous. My question for you is it more spontaneous or less spontaneous than the previous one? That previous one was a negative 70.9 kilojoules. So at 298 K, it was a negative 70 something, right? Negative 70.9 kilojoules. At 398, it was a negative 61.5 kilojoules. Since this one is more negative, it would be more spontaneous than at 398. So that's how that works. If you've got them at different temperatures, you can see which one is the most spontaneous. And that's it for part 4.